Welcome to our deep dive into Numpy's eye function. The eye function creates identity matrices, special matrices with ones on the diagonal and zeros everywhere else. Let's start with a simple example, creating a 4x4 identity matrix using np.eye of 4. This creates a 4x4 matrix. Watch as we build it step by step, placing ones on the diagonal. We can create identity matrices of any size. Let's compare 2x2, 3x3, 4x4, and 5x5 matrices side by side. Identity matrices don't have to be square. We can specify different numbers of rows and columns. Here's np.eye of 3, 6, creating a 3x6 matrix. Notice the diagonal still has ones, but extra columns are all zeros. And here's np.eye of 5, 3, creating a 5x3 matrix. The diagonal ends when we run out of columns. Now for the most interesting part, the k parameter. This shifts the diagonal up or down. Let's explore this in detail. When k equals 0, which is the default, we get the main diagonal from top left to bottom right. When k equals 1, the diagonal shifts one position to the right, moving upward in the matrix. When k equals -1, the diagonal shifts one position to the left, moving downward in the matrix. Let's see how the diagonal moves as we change k from -3 to +3.
Where do we use np.eye in real projects? Let's explore some practical applications. Here's a real example, initializing a neural network layer with an identity matrix to preserve gradient flow during training. Let's visualize what the identity matrix does geometrically. It's like a perfect mirror for vectors. Watch what happens when we multiply different vectors by the identity matrix.
Let's recap everything we've learned about np.eye today. Thanks for watching. Don't forget to experiment with different k values in your own code.